Alright, so the last time we ended up with this cute little smiley face here, and I thought this time we can wrap this smiley face up in its own function and see what other shapes we can draw, because the smiley face was only drawn with circles. So let's see if we can also make a rectangle. Alright, so the first thing to do is make my text bigger so everybody can read it better. All right, so let's see here. So yeah, if you remember last time we made a circle, well, 2 videos ago we made a circle, and then the last video we put the circle in its own function. So now let's do the same thing for the smiley face, so we can easily copy paste smiley faces all over the place if you wanted to. So I'm gonna make it in the same way, in the sense that we're good. Like the circle function only returned a mask, right, not a color. And then afterwards we multiplied by the color. We multiplied the mask by the color. We're gonna do the same thing for the smiley face. So the smiley face is only gonna return the mask of the smiley face. So I'm gonna make a function that returns a number, which is a float. And I'm gonna call it smiley. And the smiley face function needs pretty much the same parameters as the circle function, or at least they have quite a few parameters in common. First of all, we need to have the UV coordinate, because without the UV coordinate, the function will not know which pixel it is currently drawing. Also, we want to pipe in a position so that we can easily put the smiley face in different positions. So back to P. And then here we had a radius and a blur. For that, I'm just going to use a size variable, so we can vary the size of the smiley face. All right, so open bracket, close bracket. And now let's go down here and start ripping out some of this stuff here. So I'm just going to take it from here to here. I'm going to do Control X to cut it, and then I'm going to go in here, Control V to paste. And let's see here, and then let's first work on a return value. So we're making this mask here that we have to return, so return mask. And the UV that comes in is being used here. That's already fine. Now we have to just figure out the position and the size. But before we do that, let's make sure that this works the way it is right now. So let me go down here, and now instead of all of this code that used to be here, we're just going to say float mask equals smiley. And then we're gonna push in a UV coordinate, and we're gonna push in a location, which in this case I'm just gonna keep it nice and simple. And then I'm gonna push in a like a size, which we also keep simple. And the location and the size aren't used right now anyways. So let's see what this does here. All right, so there was like the green border there. Tells me that it recompiled, and the smiley face hasn't changed, which is exactly what we wanted. So basically now we have the smiley face wrapped into a function. Now we just have to make sure that we can move it with the position, and we can change the size of it. So first, to move it. So now to move it, what we'll do is the same thing as what we did to move the circle, which is basically we're moving the coordinate system as opposed to the object itself. So if you remember from the circle, like the circle basically is always drawn around around the origin. And so if we want to circle somewhere else, then we have to make sure that that point P that we want the circle to be at gets remapped to the origin. And the way we do that is by subtracting that point. So we do the same thing with the smiley. So up here, I'm going to say UV minus equals P. So now if I wanted to have my smiley, like let's say in the top right corner, then I would just, for the position P, I would just put in 0.5, 0.5, because if this is 0, 0, and this is 0.5, 0.5, then what it would do is it would take the UV coordinate at 0.5, 0.5, and then it would subtract 0.5, 0.5 off of that to remap it to 0. So basically what this does is it remaps the point that you want the smiley to be at to 0. All right, so let's see if that works. So, well, right now I still don't expect anything to change because my position is at 0. So let's first check that. So, all right, so that compiled and it didn't move it, which is what we expected. And now I can let's say move it up a little bit. And there we go. So now we have a way to move the smiley around. All right. So let's stick it back at 0. And now the other thing here is we have our size parameter. And for size, so this is translating the coordinate system here. So here, let me just say translating coordinate system. And then for size, we're going to scale the coordinate system. So we're just going to do UV times equals size. And this is scaling the coordinate system. And this should actually be divided by, but let's first see here what this does. So like again, I put in 1 for the size, so it shouldn't make a difference right now, and it doesn't. All right, so now if I want my smiley to be twice as large, then I would expect to do this, but oh no, it gets actually smaller. Why is that? Well, if we go back to 1 here, let's just see here for a moment, like where is the edge of this of the main circle of the smiley? And also let me make this a little bit sharper, because the first time we made it was a bit blurry. If you remember that this is the first circle here on the smiley, so I'm just going to make that sharper so that we can more easily see where the actual edge is. So the edge is at 0.4 from the origin. From the origin that we transformed, basically, it's the origin of like exactly the center of the smiley. So we're saying here, okay, make a circle that is exactly 0.4 big. But now if we multiply our coordinates, so originally, so this is 0.0, 0, this is 0.4, 0, right? But if we multiply this by some number, let's say by 2, well then actually it makes sense that that the smiley gets smaller and not larger, because so now let's say the point 0.2 gets multiplied by 2 to become 0.4, right? So multiplying by size here is the equivalent to dividing all of these by the same size. So what we actually have to do, like if we want this to be more intuitive, where a larger number gets you a larger graphic, then you actually want to divide instead of multiply. All right, so so now if I make my number smaller, it's gonna get smaller. And if I make my number larger, it's going to get larger. All right. Okay, so now that we have the smiley all wrapped up in a nice little function, let's just leave it for a little bit and let's see what else we can draw. So let's put this over here. Set our mask to 0. So now we just have a nice black screen. All right, yeah, so this happens sometimes. where it's complaining about the data form, about the data type. So a float is like a float is like a real number. It's like anything. It could be 1, but it could be 1.5 or minus 3.1415, whatever. But if we don't put a decimal point after this, it will think that we have an integer, which is an integer is only the natural number, so it's only 1, 2, 3, but no fractions. So I want to put a decimal point there. I don't know why it really has to complain about that, but it does. All right, so let's see if we can draw a rectangle now. So for that, let's first go to my little drawing app. And actually I drew it here already for a previous attempt at recording this video, but let me just start over and draw this from scratch. Hang on, let me just make a new page. There we go. So if you remember, we had the smooth step function, which would take in a value, like a number, and it would output like either 0, or if it would get past a certain threshold, it would go to 1, and then it would stay at 1. All right, that was our smooth step function, and it would go from 0 to 1. So this allowed us to say make a well, this allows us to draw a circle. This would also allow us to make something where let's say the screen is black on one side and it's white on the other side. So let's just implement that on its own. So well, here we could do it right here. So we could say mask equals smooth step, and now let's say I wanted black from minus 0.5 to some other negative number, minus, because the 0 is in the middle of the screen, so that's why I'm looking at minus at negative numbers, to 0.2, let's say, and then I'm gonna do it horizontally, so or like there's going to be a vertical line here, so that has to so I have to put in the x coordinate, the XUV coordinate for this. All right, so now I have where the x coordinate is smaller than minus 0.2, it's black. Where it's larger than 0.2, it's actually white, or well, it's 1. But I'm multiplying this by a mask here, so the color comes from this mask, so I could just set that to white. Yeah, so that allows us to make an edge. Now, if I take 2 edges, so let me just go back here. So that is basically the same as this. So now if I take another edge, but I do the other edge the other way around, meaning that it starts at 1 and it goes to 0 as opposed to the other way around. So let's say I have another smooth step that starts at 1 and now it goes past this one and now it goes to 0 over here. And then now, like, I mean, these should actually be drawn on top of each other because they're both 1. But anyways, this is an easier way to see it. So red starts at 1 and it goes to 0. Blue starts at 0, goes to 1. Now, if I multiply these two values together, now I get something that in the beginning, okay, well here it's 0 and 1, but something multiplied by 0 is 0. So my green line is going to be 0 here. And in between here, it's going to go to 1. And then here, it's going to go back to 0. Okay, because 1 times 1 equals 1. What did I do? Oh, 1 times 1 equals 1. And 1 times 0 equals 1. And 0 times 1 also equals, 0 times 1 is 0. 1 times 0 is also 0. So I can make a bump like this. So let's put that in a neat function, because we can use that. So let me make another function over here. There's my smiley. So I'm gonna put it right here. So that's a thing, and I call it a band because it's gonna make a band. as opposed to an edge. And a band is going to take in not a full UV coordinate, because like a band is kind of one-dimensional, right? So this only depends on the X coordinate, doesn't depend on the Y coordinate at all. So I'm gonna put in one number, and I'm not call it X or Y because that might be confusing, because we can use it for both. So I'm just gonna call it T. So I'm gonna have my band T that's gonna start at some point. Here, let me go back here. I'm gonna have these bands, and they're gonna start at some point, and I'm gonna take the middle here. So you might take different positions for the starting and the ending position. You could also take this position here or that position. I'm gonna take the exact middle. So that's gonna be my start. And this is gonna be my end, exactly in the middle here. And then I'm gonna have, similar to how with the circle we had a blur, well here we have a blur too, which is how wide the smooth step is, and the blur is this distance here, from here to here. That's my blur. And similarly, it's from here to here as well, because it's exactly in the middle. All right, that's my blur. All right, so I'm gonna go here. So now I have my float start, comma, float, not flat, float end, comma, float blur. I'm gonna close that. And so now I'm gonna have two of these smooth step functions, right? Because there are two functions here. There's the red one and there's the blue one. So we're gonna go here and we're gonna make float step 1, which is our first smooth step function, equals smooth step. And then what are the start and the end here? Well, it's not start and end, because start is here and end is here. So if we're just looking at the blue function, then we want like the start of the blue function is our start minus b, right? Start minus b is over here, and start plus b is over here. Plus blur and minus blur. So we're going to do that. So I'm going to say here it's start minus blur, comma, start plus blur. And then I'm going to put t as an input to that. All right. And then I can return my step 1. So now I could see if that works. First of all, before we go too far. So I go here, and instead of my smooth step, I'm just going to say band, even though it's not a band yet, but band. And then I'm going to input the x coordinate of my UVs, and then I'm going to say minus 0.2, comma 0.2, comma, and then my blur value, right? Let's make a small blur value. So now what I expect to see is something that starts black in the left, and then at minus 0.2, or actually at minus 0.21, it will start going white, and at minus 0.19, it's going to be completely white, and then it's going to stay white. And this second value here is not being used right now, because that value is for the other step. So, and there we go. So now we have a sharper transition that starts here. So now we just have to multiply in the second smooth step, which is the end step, which is equivalent to the red line here, which starts at 1 and goes to 0. So and it centers around end. Okay, so let's go back. So we call that step 2, and step 2 starts at end, minus blur and end plus blur. But if we did this, which you might think is the right answer, because with the start was the same thing, but like we shouldn't forget one thing, which is that the red one is the red curve is inverted. It starts at 1 and it goes to 0. So it doesn't start at 0 and go to 1. So what we have in here right now starts at 0 and goes to 1. So what we have in here right now would be something like this. It starts at 0 and then zzz, and then here it goes to 1 and then it's at 1. Okay, which is not what we want. So let me just get rid of that stroke eraser. Boom. So that's why in this case we have to switch these values around too. So we have to do plus blur and minus blur. All right. So now I could just test the other edge by saying step 2 here. And there's my other edge. And now I can just multiply those two edges together to make a band. So step 1 times step 2 makes a band. All right. So now that we have the band, like you could see that very similarly to what we did with the two edges multiplied by each other. Well, we can multiply two bands by each other to make a rectangle. So let's do that. So I go over here, I make a float called rect for rectangle. And my rectangle, as opposed to the band, which only takes a one-dimensional input, our rectangle does take a two-dimensional input. So we're just going to do rect2 uv. And then I'm going to have to make a bunch of variables for the start and end values for all these for all the edges. So I'm going to do float left, comma, which is the left side of the rectangle, float, not float, float right, comma, float bottom, comma, float top, comma, float blur. All right, it's getting a little bit long and cumbersome. All right, and then close bracket, open curly brace, close curly brace. All right, so now exactly the same way as the band was made, we're gonna make the rect out of bands. So we make a band out of smooth steps, we make a rect out of bands. So I'm gonna do the same thing. So float band 1 equals band, and then my band 1 is going to be, let's say, the vertical band, so it's going to take the x coordinate, right? Because a vertical band is dependent on the x coordinate, not on the y coordinate, because it's the same for every y, right? So that's why we put in the x. The first edge on our band is at left, and the second edge of our band is at right, and we're just going to pass in the blur value as well. All right, and then we're going to return band 1. And let me just go down here, and instead of band, I'm going to use the rect now. Rect, and then I'm going to, I have to put in my full UV coordinate. And now I'm gonna, let's say, leave this the same, but now I need to add two extra values here for the bottom and the top. So let's make it minus 0.3, comma 0.3. And then our blur value is something like this. So let's see what that does. All right, so nothing changed, which is great because it's exactly what I expected, because we only have one band. So now let's make the second band. Copy it, Control C, Control V. And there's our second band, band 2. And our second band is dependent on the y coordinate because it's a horizontal band. So there we go. And it's gonna take the bottom and the top value. All right, so now I can test just my band 2 first to see if I didn't make any mistakes. So there's my band 2 horizontal. So now I can just multiply my band 1 by band 2. Band 1 times band 2. And we have a rectangle, yay! So yeah, so that's the way to make a rectangle. Now, like, you could make it in a different way. You could make it that because now our rectangle takes in the positions of all the edges, right? The left, the right, the top, the bottom. Sometimes it's easier to make a rect function that takes in a position and a size, for instance. but you can figure that out yourself. Thanks for watching.